Okay, this is the second example for graphing, and it's a little bit drawn out, but it's going to take 3 videos. But we need to learn how to do it. You might have a problem that involves graphing on your test. If you do, I promise you there will only be one, if there's any. Okay, you're given f of x equals 1/8 times x to the 2/3 times parentheses 9x squared minus 8x minus 16. Find part A, intervals of increase and decrease, part B, local min and max, part C, intervals of concavity, and part D, sketch. So it's exactly the same question as a previous example, but now we have a different function. Now don't forget, you've got examples in your text. I'm not even doing those. You go into that text and you look at those as well, and then get through that homework so to see that you understand it. Okay, now I'm going to start as I did in the last example, not with part A, but by doing these different steps. And the first one is to find the critical numbers for f, f prime, f double prime. Okay, so first we're going to look at f of x. Let's go ahead and try to factor that. F of x is equal to, these are actually the zeros of f of x. We have 1/8 times x to the 2/3 times 9x squared minus 8x minus 16. Set that equal to 0 and solve. It's going to take, first of all, the first factor, set that equal to 0. 1/8 x to the 2/3 equals 0. That's nice. That gives you x equals 0. But the other factor, 9x squared minus 8x minus 16, that sucker's not going to factor. You're going to have to use a quadratic formula. Okay, and when you do, it simplifies to x equals 4 plus or minus 4. Oh, we're over there. It simplifies to x equals 4 plus or minus 4 times the square root of 10 over 9. You'll see that's where we're going. And we can't simplify that any further. It's irrational, so we're going to estimate. We're going to estimate that's x approximately 1.85 and x approximately negative 0.96. So thus we found the zeros of the function f. They are 0, 1.85, and negative 0.96. Now let's take f prime of x. It's a derivative of 9/8 times x to the 8/3 minus x to the 5/3 minus 2x to the 2/3. And I actually got that by distributing 1/8 times x to the 2/3 across a parenthesis in f of x. Take the derivative using the power rule and then factor f prime. Well, first, if you take the derivative using the power rule, you get 3x to the 5/3 minus 5/3 x to the 2/3 minus 4/3 x to the negative 1/3. Okay, that was easy enough. Now, I actually enjoyed figuring out how to factor the top. I did an x minus 1. I was using synthetic division, things that we learned in high school algebra or college algebra. We got x minus 1 times 9x plus 4 over 3x to the 1/3. So set each of those factors equal to 0. And you're going to get, first, for the first factor, you get 3 times x to the 1/3 equals 0, gives you x equals 0. Then the other factor, x minus 1 equals 0, gives you x equals 1. And then 9x plus 4 equals 0, gives you x equals negative 4/9. So we found the zeros of the numerator and the denominator. So those are our critical numbers. Those are our critical numbers of f. They are 1, negative 4/9, and 0. They're the zeros of f prime plus the value of x where the function's undefined, where f prime's undefined. Now let's figure out what f double prime of x is. Well, I multiplied through, I took f prime of x before I factored it, and I used that to take the derivative for f double prime. I got 5x to the 2/3 minus 10/9 x to the negative 1/3 plus 4/9 x to the negative 4/3. And then I found that I couldn't factor that sucker. It was horrible. At least I was able to write it when I simplified it as 45x squared minus 10x plus 4 over 9x to the 4/3. So in that situation, I was able to set the bottom equal to 0 and then set the top equal to 0. And that would give me the critical numbers of f prime. Remember, the critical numbers of f prime are the zeros or the values for which f double prime does not exist. So we get x equals 0 for the denominator, and for the numerator, again, I have to pull out the quadratic formula, and that simplifies to x equals 10 plus or minus the square root of, it turns out to be negative 620 over 90. Hey, wait a minute, x equals not a real number. We throw that sucker away. We don't deal with imaginary numbers here. Thus, the critical numbers of f prime are going to be the zeros of f double prime, which is x equals not real in this particular case, and the values of x for which f double prime does not exist. That occurs when the denominator is equal to 0, and that gave us x equals 0. Think about it. I'm pretty sure I got that all right. I thought about it a lot before I wrote it down. Okay, so the critical numbers of f prime are, there's where the mistake is. I shouldn't say the critical numbers of f double prime, but I should say the critical numbers of f prime are the value x equals 0, because that's the value where f double prime does not exist. So that's called the critical number of f prime, not f double prime. Okay? Yeah, let me just pause here and remind you, why do I keep tripping over this idea? Because to be a critical number of f means that your x equals c, where f prime of c is either equal to 0 or does not exist. So to be the critical number of f prime, you are the value x equals c, where f double prime is either equal to 0 or does not exist. Okay. On to the next video to continue this problem.